first type of reaction we're going to look at is a precipitation reaction. And this just means when we look at the solubility rules, if we react two things together and it's insoluble, okay, that means it stays as a solid, it doesn't dissolve, then this is a precipitation reaction. So basically, I mix two things together, okay? What it formed does not dissolve, it stays as a soluble, it's insoluble. That's called a precipitate, okay? Which is a fancy word meaning it's insoluble. So let's look at this. MgCO3, how do I know that's going to stay as a solid? Well, I go back to my precipitation rules here. MgCO3, here's CO3. It says all alkali metals and NH4 phosphates are soluble. Okay? Well, this is not an alkali metal, it's an alkali earth metal, Mg, because I'm forming MgCO3, so that will be insoluble. So according to my rules, this is insoluble. So if it's insoluble, that means it does not dissolve, so it'll stay as a solid in water. And that solid is called a precipitate, okay? So that's a precipitation reaction, okay? When you mix the two things together, it forms a solid because it's insoluble, and that's a precipitation reaction. Okay, so let's look at how you write these. Here's rules. You write the two reactants in a chemical equation. You write the formula of the product by switching the cation and anion. Balance the charges. Use solubility rule. If all the products are insoluble, no precipitate forms. Okay, so let's look at a reaction. Let's look at the one we just looked at, actually. So if I dissolve, let's say, if I have magnesium 2 plus and carbonate 2 minus, okay, what will that form, and will this be a precipitation reaction or not? Alright, so first let's look up, we're going to, these are going to form together, okay, they're going to react together to form MgCO3. Now let's make sure this is balanced, okay? I have a 2 plus charge and a 2 minus charge. When I add those together, are those 0? Yes. So I don't have to do anything fancy. Let me do a hypothetical. Let's say I have like sodium carbonate. So that would be a +1 and a -2. Okay. Now I have a I don't know why this is not responding well. NaCO3. Okay. But are these balanced? Okay. No, I need 2 of these to neutralize that charge. So it's going to be Na2, meaning I need 2 of those, and so over here it'll actually be 2 Nas. So I need 2 sodiums to balance out the carbonate, so I need to reflect that over here. There's going to be 2 of those, and also over here is saying I'm going to have 2 of those. Alright, this is balanced over here, the charges, so I don't need to add anything, so this stays as MgCO3. Now let's look at both of these and see if they will dissolve. Okay, so MgCO3. Let's look at our solubility rules. So CO3, only alkali metals and NH4 phosphates are soluble. Well, magnesium is an alkali earth metal, so that doesn't apply, so it's insoluble. If it's insoluble, we say it stays as a solid, meaning it doesn't dissolve. Oops. Okay, so this is a precipitate. That's fancy for saying it's going to stay as a solid. Now let's look at this one, Na2CO3. Again, I'm reading the rule for CO3. It says alkali metals and NH4. Well, Na is a alkali metal, because if you remember from chapter, I think 1, that means a group 1. Sodium is a group 1 metal. So this one, okay, when you see AQ, it's aqueous, which basically means it dissolves, okay? So this is not a precipitate reaction, not a PPT. Okay, so you basically say no reaction, okay, because it will not form a precipitate, because that's what we're looking for. Will it form a precipitate or not? This one is no, okay, because it says it dissolves. This one is yes, because it's insoluble. So you're trying to see if your product forms something insoluble, according to the solubility rules. If so, it's a precipitation reaction. Okay, so let's look at a whole equation. Because this is how you're going to see it more often, is they'll give you an equation, a molecular overall equation, and they'll ask you what is the ionic equation and what is the net ionic, okay? A molecular or the whole equation is where they show everything. You know, they're going to say sodium chloride reacts with silver nitrate to make silver chloride and sodium nitrate. You know, so it's the whole overall equation. You see the aqueous. Aqueous means it dissolves. And so on here, is this a precipitation reaction? Yes, because one of them stays as a solid. Okay, that's how I know. Okay, now what you do to get the ionic equation, do you see everything that has the aqueous? That means it dissolves. So you have to write it in its ions, because they dissolve. If it dissolves, it breaks up into ions. Now, do you see the solid here? That means it will not dissolve. It'll stay like that. So do you see AgCl? We don't write it in its plus and minus form. We leave it as a solid. So net ionic, we're going to cancel everything out on both sides of the equation and leave you with your net ionic equation. Notice that you see your solid was the silver chloride. And look, that stayed as a solid, and your net ionic equation, it was just how to make that solid. So chloride and silver reacting together to make your solid. So let's do a full example. Here we go. Okay. I have, come over here. I already forgot. 3 SrCl2. Okay. I have 3 SrCl2, and this one is aqueous. That's important to know because that means it will dissolve. Plus 2 Li3PO4. Oops. 2 Li3PO4, and that one was aqueous. And this will react together to form strontium phosphate. Sorry, 3PO4, 2. That's a solid, so that one will not break up. And then I don't remember the other one. 6 lithium chlorides. Plus 6 lithium chlorides. So in a problem, oh, and this is aqueous. Usually what it'll say is write the net ionic equation. Okay, and how you do this, let me turn some of these things off. Maybe my computer will run better. Maybe. Okay. the net ionic equation is, after you cancel everything out. So do you see everything that says aqueous? That means it's going to break up in its ions, okay? So let's start here. Do you see I have SrCl2, but I have 3 of these, so I need to, show that. So my my ionic equation, where it has all of the ions broken up, will have a Sr. I'm going to have 3 of them because it says I have 3, right here. Now what's the charge of it? Well, let's think about this. Let me put on here the chlorines. How many chlorines will I have? Do you say I have 3 and 2? So I'll actually have 6 chlorines. Because it says I have 2 chlorines here, but I have 3 of the 2 chlorines, so it's always 3 times 2. So it's always going to be your coefficient multiplied by your subscript. So I have 6 chlorines, okay? And we know the charge of chlorine. It's a -1, okay? Because it's in group 7. So if these have to neutralize each other because they're together. I have 6 of these with -1, so what's the charge of this if I have 3? That'd be a +2. Right? I go 6 times 1, that'd be -6, so I need this to be a +6. I have 3 of them, so 3 times 2 is 6. Okay? So this is a +2, or if you want to, you could just switch the coefficients. So do you see that there's a 1 coefficient here, so up here that would mean chlorine would be a -1, and this is a 2, so that would be a +2. Okay, just by switching those over, okay, the superscripts, or the subscripts, sorry, switching those over. So let's practice again with the next one. So now this one needs to break into its ions. Okay, so I have lithium. How many lithiums do I have? Remember, I would do 2 times 3, which would be 6. 6 lithiums. Okay? Now let me put parentheses around this. This is a polyatomic. How many of these do I have? Just 1, right? Just 1 PO4. So that means this is going to be a +1. Or if you want, lithium on the periodic table, let me pull this up. Lithium is in group 1, so that's a +1 charge. Okay. Plus, okay, PO4. Now how many PO4s do I have total once you add in the coefficient here? So there's 2. There's 1 right here listed, times 2, so that would be 2. So what charge is this? Okay, I have 6 with a +1 charge, so that's kind of like a 6+, if you want. And I have 2 here, so how can I form what multiplied by 2 equals to 6? Because I need this to be a 6 minus when it's multiplied together. And that would be a 3+, right? 2 times 3 would be, or not 3+, 3 minus. Because 2 times 3 is 6, right? Just right here, 6. I have 6 plus 1 charges, so that's like having a 6 plus charges. Here I have 2, 3 minus charges, which gives me a 6 minus. Okay, now let's go to the next one. Now this one's easy. It's a solid, right? This says solid, so it doesn't break up, so it's going to stay exactly like that. So it will be, you don't have to do anything to it, you just rewrite it. SR3 PO4 2, and this stays as a solid. Okay, now plus, let's do the next one. Lithium, how many lithiums will I have? 6. 6 lithium. That's a +1 charge because it's in group 1. Plus, how many chlorines here? 6. And -1 because it's in group 7. Okay, now I want to cancel everything out. Okay. Do you see that I have 6 chlorines with a -1 charge over here, and 6 chlorines with a -1 charge over here? So those will cancel out with each other. cancel, cancel. Okay? Now over here I have 6 lithiums and 6 lithiums, so those will cancel. So cancel and cancel. Will anything else cancel? No, because I don't have just 2 PO4s by itself. This is a solid, so it's not broken up. Okay? So that gives me my net ionic equation, net. Okay? And basically I write down everything that didn't cancel out, which is this, and this, and this. Your solid never cancels out. Basically your net ionic is showing how you made your solid. So my solid is SR3 PO4 2. That's my solid. Okay? And what makes that up? 3 strontium with a 2 plus charge plus 2 PO4 with a 3 minus. Again, do you see everything canceled out except what makes up my solid? And my solid is made up of strontium. You see there's 3 of them. So there's 3 over here. It's made up of PO4. Notice there's 2 of them. So it'd be 2 over here. And so they'll ask, so a lot of times in a problem, they'll say, okay, here is your overall molecular equation. What is the net equation? And the net equation is always this last one here, and it's basically the equation of how to make your solid. So let's do one more. Let's do the one I had in the example, actually. Here it is. Okay. So it is sodium chloride. This one is aqueous. Plus AgNO3. O3. And this one is aqueous. And what do we make? AgCl, solid. Plus NaNO3. NaNO3. And this one's aqueous. This is going to be an easier one because there's no coefficients. When there's a coefficient, you have like a number in front of these, then you have to multiply everything by that number like we did before. But there's no numbers in front of them, so it'll be a little bit easier. So we want to find the net ionic. So remember, the net ionic is basically how to make our solid. So if I kind of start writing down here and put net, I know for sure in my net it's going to be on this side AgCl solid. Why? Because again, it's always how to make up that solid. So now let's do our full ionic equation. Ionic. And let me change the color to seafoam green. Now let's break up everything that's aqueous. Okay, so I have first sodium chloride. So I have Na, and I only have 1 sodium plus chloride, and I only have 1 chloride. What are the charges? Na is a +1 because it's in group 1, and chlorine is a -1 because it's in group 7. So you see I only have 1 of those, 1 of each of those. Okay, let's look up there. Silver nitrate plus a silver. I only have 1 silver. And then nitrate, I only have 1. Remember, nitrate's a polyatomic ion. That's how I know I write it all together. So you have to, again, become familiar with your polyatomic ions to know when to keep them together. Nitrate of your periodic table, or your so your polyatomic ions has a -1 charge, and that's just from your polyatomic ion chart that I gave you. So if that's a -1, there's only 1 silver, so what's the charge of that? +1. Okay? Now let's see here, we have our AgCl, and this is going to stay together because it's our solid. Plus sodium, again, is going to be a +1 charge. And then plus, I can write it over here, NO3. We already said NO3 has a -1 charge. Okay, so now let's cancel everything out. We use this color. Sodium over here, sodium over there, so those will cancel. NO3 here, cancel. And there's a NO3 right here. Anything else? Nope. So this is what's left over. So I told you AgCl will be left over. And how do we make that? Okay, with these here. So I'll have a Cl -1 react with 1 silver with a +1 charge. And that gives you our solid. So you see 1 chlorine plus 1 silver reacts together to make silver chloride. Anyway, so that's how you do it. You're going to have your overall equation, and then your net equation will show you how to get to that solid. So practice some of those with the homework. And the next podcast we'll go over acids and bases a little bit.